Question number 1 wants to know which of these species could be reduced to form NO2. Looking at NO2, I can deduce that NO2, the nitrogen must have a +4 charge since the two oxygen each have a -2. So that means one of these species has to have a higher oxidation number in order to be reduced to that, in order to gain electrons. So with N2O, oxygen being -2 would leave each nitrogen with a +1 charge, so that wouldn't be reduced. NO3 -1, oxygen's a -2 for a total -6. That would leave this nitrogen at a +5, so this could be reduced. HNO2, I've got a +1 and a -2, leaving this nitrogen as a +3, so that won't work. And NO is going to be a -2, leaving this nitrogen at a +2. So only B could be reduced to form NO2. Number 6, in the reaction of NH4 plus to form NO2 minus, what is the correct description of the change in oxidation state of nitrogen? So if I look at NH4 plus, I've got 4 hydrogen at a +1 each, and I want a +1 overall charge. So my nitrogen is a -3 state in NH4 plus. In NO2 -1, I've got 2 oxygen at a -2 for a -1 overall. So in this case, my one nitrogen is in a +3 state. So if I go from -3 to +3, that's an increase of 6. So letter C would be my correct choice. It's important to remember, though, even though the oxidation number is increasing by 6, it's actually a loss of control over 6 electrons. Number 10, in which of the conversions below is chlorine oxidized? So oxidized, I will see an increase in the oxidation number as it loses electrons. So in number 1, I have Cl2 with chlorine at a 0, OCl minus, the oxygen's a -2, so the chlorine's a +1 in order for that to be OCl minus. So yes, in this case, chlorine is oxidized. In reaction 2, I have Cl2 plus I2 forming 2ICl. So in this case, the chlorine and iodine are both 0. Over here, chlorine is going to take control and be a -1. It's going to take control of the electron, and iodine would be the +1. So in this case, no, it's being reduced. It's gaining electrons. And number 3, I've got OCl minus. Well, the oxygen's a -2, leaving the chlorine a +1. And then I have ClO3 minus. So my oxygen's a total of -6, which leaves a +5 for my chlorine. So in 1 and 3 both, it is being oxidized, so letter D would be the correct choice. In number 15, deduce the oxidation number of cobalt in the following species. In the first one, I have, in letter A here, I have CO, H2O6, and then I've got these parentheses 2+. Well, just like you would think, H2O is going to be neutral. Okay, so it doesn't matter if there's 6 of them. This +2 charge, that all belongs to the CO. So in this case, my CO has got an oxidation state of +2. In letter B, I've got CO2, SO4, 3, and I should realize that sulfate has a -2 charge. So this is a -6 charge from the sulfate. So my 2 cobalt need to have a +6 charge. So my cobalt are each +3 in letter B. And letter C, I've got CO, Cl4 with a -2 charge overall on it, or 2-, I guess I should say. I know the 4 chlorine are going to be a -1 each for a total of -4. So my cobalt here would again be a +2.